So I asked my wife, what do you mean exactly tell more about myself? And she said, say your name, what's your age, how many kids do you have? So I went ahead and created an application that shows my name, shows my age, and how many kids do I have. And I really prepared hard, I prepared all the images and GIFs and videos and explanation and whatnot. And I was pretty excited. I came back to my wife, I showed her that, and all she had to say was, you idiot, you're only 37, you're not 38. So even though it's biographically not correct, technically wise, this Elm application is working correctly. So my name is Amitai. Amitaibu is my GitHub and Twitter nickname. I'm the CTO and co-owner of Gizra. We're a web development shop in Tel Aviv. We're about 20 people in Israel, 2 people in the US, 1 person in Europe, in Brussels. We have fancy clients like Harvard University, the UN, the European Commission, and so on and so on. But today what I'd like to tell you more is about Elm and the Elm architecture. And I'll just call it Elm, right? I mean, in the end, Elm is the language and Elm is the Elm architecture. It's kind of the mindset of how to approach an application. What is the app flow? What is the components hierarchy? Or we could call it even the best practices. So Elm architecture basically says every component, and we'll quickly see what a component is, every component has a model, an update, and a view. And even if you're not familiar enough with Elm, I can assure you that after the presentation you'll still not be familiar enough, but you'll start understanding the mindset, or what I like to call how to think Elm. So again, a quick look at what we're going to talk about. This application, which is very, very similar to the default counter application that we see as the first example in Elm. It just shows my name, it shows my incorrect age, and it gives the kids number that I have that I can increment and decrement. And you can see here on the bottom, this is just for debug, I'm just spitting out all the information. So let's start to see how we are writing Elm. Again, if you're not too familiar with the syntax, just follow along. You'll see it's much easier than you might think. So we have a model called person. We're doing an import over here, quite similar to require, if you know from JavaScript. But the interesting things are starting to happen here on the model. And luckily, thanks to the alphabet, model, update, view, M, U, V, it's going by order. So let's start with the model. We're saying this is my model. I'm starting to think data. So what do I have to show? I have my age, it's an integer. I have the number of kids, it's an integer. And I have my name, it's a string. I can initialize the model over here. I'm now hard coding it to my personal biography. Watch me as I'm completely disregarding this init function, and I'm arriving immediately to this type action. And if you've seen earlier presentations that I've done about Elm, you know that I'm super excited, almost on the verge of freaking out over this one line. Because this action is basically telling all the different actions that can happen on my model. Decrement and increment, and that's it. And if you're coming from Angular 1, for example, and I would ask you on your big application, and even if you've started it and you're the senior developer, if I'll ask you, hey dude, what kind of actions can you do on your model? You'd have to scratch your head, look in the code, and start looking in different places, because some things are happening in the model, some things are happening in the view. But over here, Elm is very, very explicit, and it's saying, no, there's one single place that we declare our action, decrement and increment. That's it. You cannot have anything else. These two, this model and the action, for me, that's the most important thing. That's like the base of our component. Next, we'll see the update function, but in a way, I'm always calling the update function an implementation detail. It's just an engineering problem. I'm gonna get an action, I'm gonna get my model, and then I need to return back a new model. So Elm is an immutable language, which is awesome, which basically means that when I'm getting one model, I'm not gonna reassign that model. I cannot. Even if I try to, Elm will not let me. I'm returning a new model. So basically what we're saying over here, I'm gonna get an action, I'm gonna get a model, I'm gonna return a new model, completely ignore the effect for now. We don't care about it. So if the action is decrement, then take my model and just say the kids property, just take the one that you got from the model and decrement it by 1. Bonus points for if you can imagine what happens on the increment. So we have the model and we have the update. As simple as that. Now let's look at the view. Now when we're looking at the view, it might look similar to HTML. It's not HTML. It looks weird, and I always like to say about this Elm HTML syntax, it's just syntax. Deal with it. Deal with it. It has its advantages, it has disadvantages. The disadvantages is probably that you're not used to it. The advantages, though, are that it's compiled. You cannot forget a closing bracket. You cannot write div with an E instead of an I because the compiler will catch you. So again, it might not be very natural at first, but it's pretty powerful. What we're saying over here, again, let's ignore the arguments that we're getting, but in a sense we're saying we're gonna have a div, and under that we'll have another div that is saying name is model name, that's the model that we got, and we take this value and we put it under a text. What is exactly a text? I'm not gonna get into it. It's just an Elm thing. Again, you just need to know it. Once you start developing yourself, it will become more natural. The next thing that we're seeing, we have here the age. The age is an integer, so I need to string it to cast it into string, and again, pass it on to text. Same thing with kids number to string model kids, and then I have the different buttons that will know how to decrement and increment. Again, this is tightly coupled with the action that I've previously declared, and then I'm just, spitting out an output of the entire model. And, even though I said this is syntax and deal with it, definitely there's a bit too much going on here. Let's start cleaning this view function, and while doing it, we can realize that everything in Elm is a function. So here I have this view function, but I can start breaking it down to smaller functions. So I would say here, I have a new function called viewName. It will get a string and it will return an HTML. So looking here on top, I see viewName, I'm passing the model name, and in return I'm just gonna get this piece of div, this piece of Elm HTML. Same thing goes with viewAge, where I'm passing the model age. I'm saying viewAge is getting an integer and it's now returning an HTML. And of course, same thing for viewKids, right? Looks pretty perfect. I'm going over here. I'm going to be super excited to show you how I was able to break down the view function, but then I realize, oh my god, I have a bug, a runtime bug. How embarrassing. I'm sure you never had this kind of bug because we're all talented developers. But look, the name is right, the age is right, but the kids number is really, really challenging. I mean, both economically and also in terms of my relationship with my wife. If I had 38 kids, that would be wrong. And I'm seeing that the model is right. Down in the debug area, the age is 38, the kids is 3. What happened over here? Let's go back and see our view function. Oh my god, how embarrassing. I didn't pay attention, and the view age I passed the model age, and the view kids I passed the model age as well. Elm is so powerful in the sense that it allows us to start moving some of the runtime errors, or let's call it the runtime bugs. Like Elm is guaranteed, there's not going to be a runtime exception, but I'm calling a runtime error or a runtime bug. We're able, using simple techniques, to convert them into compiler errors. So let's have a types 101. So in Elm we can define a boolean, and this is actually the way a boolean is defined in Elm's core, we're saying type bool equals false or true. That's it. These are the two values that boolean can have. Let's jump again forward to our own model, and let's say that I would like to show you also what kind of vehicle that I have. And as the CTO of Gizra, you can imagine that I'm stinking rich, so I could have either a boat or a plane or a car, but we are saying that car also comes with a certain integer, because I can have one single boat, right? It will be ridiculous, I'll have more than one single boat. I can have one single plane, again, I'm not that greedy, I just like one single plane, but I could have multiple cars. So the integer over here will say, I have a car and the number of cars that I own, and then in my model I'll see here, this is my name, it comes with a string, and I have a property called vehicle, which is actually the type of vehicle. So basically what we're talking about is type safety. Let's take the idea of type safety and look at it in our existing model. So our existing model is saying age is integer and kids an integer. And we saw it was a problem, because when we passed model age into kids, it worked, right? But we don't want it to work. So what we're able to say is, let's define our own type. Let's call it type kids, which is equal kids that is getting an integer, similar to what we saw with the car. What we were actually saying is, have an integer but wrap it with a new type called kids. So just for the example, I keep the age as integer, and the kids is now getting a kids type. Looking at the initial model, the age is 38 because it's just an integer. It doesn't know more information about it. But the kids, it now requires a kids type. It has this metadata of calling kids, where saying, the kid you are getting, I cannot pass you just 3. It's a kids type with the 3 value. So this means that when we change this type, this is the view before the change, the view kids, earlier we saw, it's getting the integer, right? But now, if I'm doing this, if I'm adding this type, I will get a compiler error over here, because it is going to expect kids, right? The view kids is now getting kids, and it's going to return the HTML. So we're adding a bit more code over here. What we're doing is, you need to realize that the integer that I have is wrapped with the kids type. So over here, what I'm actually saying, I'm getting the kids as the value. So I'm saying kids val equal kids, which is basically unwrapping. It's able to reach in, take the integer, and now our integer, the number of kids, is actually inside this property, variable. So now I'm able to say here, div kids number is toString val. And in fact, by doing this change, now I assist the compiler to assist me, in the sense that here I'm seeing the compiler error. This is a screenshot from Atom, because Atom could easily integrate with Elm. I'm seeing the argument function for viewKids is expecting kids. You cannot pass it an integer. And this is beautiful, because I'm preventing runtime bugs by adding those types. So same kind of change we'll have to do in the update function. So here is before the change, right? The kids, this part is just assuming the model kid is a simple integer. This is how it will look once we add this type safety. Again, very similar to what we had before. Get the kids, unwrap it from the model kids. Here we have the value, and the new kids value, here this symbol that you see over here, this single quote that you see over here, is usually, this is like a standard of saying, I have a variable called kids. Again, it's immutable, I cannot reassign it, I'm creating a new variable from it. So this basically says the origin of this value is coming from kids. So kids with a single quote is actually equal to val minus 1. And again, I must wrap it again under kids, and then reassign it in our model. Alright, So type safety is there. I cannot pass the age to the kid's number. But there is another thing that sometimes we need to bake some business logic into our application, obviously. And the great thing about Elm is that I'm able to bake my business logic from the data level. So let's say, as we are seeing over here, the kid's number is -1. That doesn't really make sense. And let's say, for the sake of argument, that I want to give a limit, so I cannot go in the kid's number below 0, or I could not go below 5. You can see in this video that indeed, even though I'm clicking the plus and the minus, it won't go up or it won't go down. And again, if you're gonna apply this Angular 1 mindset to it and thinking, okay, two-way data binding, which we love back in the years and now we really hate, because it's one of the origins of all the evil stuff. How would you do it? I mean, what, you would disable the HTML? That's possible, but again, this is just touching the HTML. This is not thinking from the data level, or you'd have to, listen to the scope change and allow it or disallow it. And one of the fun things is, like we said, is Elm is unidirectional. When you're doing something in the view, when you're clicking a button, it absolutely does nothing to the model, which is great. It might make things a little bit more verbose, but you have total control over the application. When you're clicking on the button, the only thing that happens is that you are firing the model itself along with the action to the update function, and you will say, listen, update function, please try to increment now according to this existing model. So again, we're seeing the model before a change, and after the change, it would look like that. But we're basically saying here, the kids, if the value should go below 0, just keep it as kids 0, otherwise do the change. There is only one single place where our model can change based on a certain action, and this is over here, and this is over here. So when you're seeing bugs on your business logic, you don't need to start digging around different files. You know exactly where it's happening. So the compiler with this type safety and the type system basically helps us prevent some compiler errors or sometimes runtime errors. But over here I have some business logic where the type system, maybe I could really force it to somehow help me, but it would look weird. So what I'm saying is business logic requires testing. So when I presented this presentation in fluent Hebrew in the meetup of Tel Aviv, I asked the people, please raise your hands who enjoys writing unit tests. And believe it or not many people raised their hand. It was actually 0 people. So who is writing unit tests? We try to do it from time to time, but in the end you end up writing the unit test for the really simple stuff, but you're not writing the unit test for the hardcore stuff, because then you need to start mocking the entire world and HTTP request and whatnot. And Elm makes unit testing really simple, or I should be careful with the word simple, because I remember myself when I saw for the first time how tests are written, I was a little afraid. I immediately closed the file. So I just want to show you the test. Again, this is a bit more advanced. You don't need to remember everything. This is just to remove a bit the fear factor and show you how things can be done. So basically we have this test, okay? We have here this type test, and we have a test suite, and we can say test that the 0 count. So whenever I'm updating kids, we'll see what this update kids function is, and I'm passing an action called person decrement with an initial value of 0, it should still remain as 0. But again, let's see a bit the syntax. What we have here the suite, the name of it, the test, the name of the test, negative count, and basically we're saying just assert equal that 0 equals 1, let's say. And obviously when I'm gonna run this test through my browser or through Travis, for example, continuous integration, it will say, hey, dude, something is wrong over here. So when we're looking at a more complete test suite, we can see that we want to see, for example, that if kids is 0, it should remain 0. If kids is 1 and I'm decrementing it, then it should return 0. Very quickly, let's look at the update function. We can see that the update function is taking an action, a person action, and it's taking an integer, which is the number of initial kids, and then in the end, it's gonna return us the number of kids after applying the update function over here. So here I'm initializing the model and I'm setting the number of kids. Again, this might be a little more advanced. Don't deal with it too much. Just know that we're able to do it with a very limited amount of lines. And here I'm creating a new model that basically I'm calling the person update. That function that we saw with the update, please pass the action, please pass the model that I've just very quickly mocked up, and then, you know, just get the number of kids from it and return it. And it's either gonna work or it's either not gonna work, but what's fun about functional programming is, again, you're just calling the function with all the arguments and you're guaranteed to get the same result over and over again. So you can see my presentation is on GitHub, both the slides and both the code. It was scaffolded from a Yeoman generator called Yo-Elmlang. It's a homegrown Yo generator it's homegrown in Gizra, and the fun part of it is that it's already coming integrated, for example, a part of all the best practices and startup and package, all the different packages and gulp to allow you to easily start it. It's already coming integrated with Travis, which basically is saying the minute you start your project, you can already go ahead and start the testing. That's it, folks. Hope you enjoyed the presentation, learned a bit about Elm. I would love to get some tweets if you have questions or comments, and till the next time. Cheers!